Welcome to the lecture series on numerical methods, finite difference approach. In the present lecture, we will discuss about first order hyperbolic equations using Wendroff's method, followed with some examples. So, if you will just go for this hyperbolic equation of first order, so especially these equations are written in the form of like del u by del t plus c del u by del x, this equals to 0. And for a well posedness of this problem, we will have like two conditions it is required, one initial condition and one boundary condition there itself. And if you will just see here this coefficient c, especially that depends on this like physical phenomenon of this problem, that how this problem is occurring in a system. Sometimes in the heat transfer problems, we are just considering c as the like specific heat capacity. Sometimes in the wave equation, we can just consider this as the wave parameters. So, likewise in different scenarios or different physical behavior, we can just consider these coefficients in different forms. And if you will just consider this problem as a initial value problem, where x and x is just varying in the space coordinates and t is just varying in the time scale, then this initial and boundary conditions are prescribed as like u of x 0 equals to x, and this boundary condition it is just prescribed as u of 0 t equals to t there. So, suppose the solution is required over a space domain, that this space domain in the x axis it is just varying from 0 to L here. For all t greater or equal to 0, we have to find the solution there. And for this, we will just discretize this x space coordinates into several small grids, which is of like a grid length as a del x. And if you will just find a particular coordinate as suppose xi here, which can be written as I delta x here. And the starting point we are just considering as x 0 equals to 0 here, and the end point is just considered as x n equals to L here. Hence, we can just consider that I is just varying from 0 to n here, and for each of this grid sizes of length del x is placed. And if you will just consider the time increments here, suppose del t is the small time increment in the first level here, and proceeds with the steps as del t in each step says. And after suppose the jth step, we can just say that this time is just moving up to the level j del t there. And if we want to find the unknown at a level suppose I j plus 1 here, then the values of u at I jth level should be known to us here. Since always we will have a boundary condition which is prescribed along this boundary or in the x surface here, and if we will just consider this known values as u 0 j as the boundary conditions here, that is prescribed at x equals to 0. So, which is just prescribed at t equals to 0, initially we can just consider that one as. And if we will just proceed, then we can just discretize this complete domain as defined in this picture here. That is x 0 equals to 0 is the starting point, and x n equals to L is the end point here. We are just dividing this total x axis or x space as n coordinates here, that each of length of del x here. So, similarly, we can just assume this time scale coordinates as a del t here, and each of these time increments it is just added this del t at each of these levels there. So, that is why at t jth level we will have this coordinate as j del t there. So, if you will just go for Wendroff's method here, Wendroff's formula especially it is just obtained by discretizing this partial differential equation, which is just defined as del u by del t, this plus c del u by del x, this as 0 here for x greater than 0 and t greater than 0 here. We can just consider this point of discretization at the halfway between xi plus 1 and tj plus 1 here. So, if suppose we will just consider ij coordinate is this point here, then we can just consider we are just moving here I plus half here, and we are just moving j plus half here. So, especially this is the point where especially this computation will go ahead. So, that is why we are just considering as the point mass point as I plus half and j plus half there, and both the derivatives are approximated by central differences here. And if you will just discretize this del u by del t term at the point like I plus half and j plus half using central difference scheme here, then we can just write this one as u I plus half. This is half point, again it will just additive of, so that is why it is just taken as a j plus 1 there, minus u I plus half. So, j plus half minus half it is there, so that is why it is just taken as j point there, by del t plus c I plus 1, since we are just considering I plus half there. So, that is why this is just coming as I plus 1 there. So, j plus half it is there, minus u I plus half minus half it is there. So, that is why it is just taken as I there itself and j plus half it is there. So, and if you especially if you will just see here, so that is nothing but if you can just see. So, this time matching it is also just going to del t by 2. So, 2 into 2 it is just cancel it out, and del x by 2. So, that is why it is 2 and 2 it is just cancel it out. So, if you just replace these halfway derivatives by the corresponding average values again and neglecting the error terms, we can just write this one as, since we have this point as in the form of u I plus half j plus 1, since I plus half point especially we do not know what is the exact value of u there itself. So, that is why we have to take the average of I plus 1 point and I point there itself. So, that is why this point is just replaced as u I plus 1 j plus 1 plus u I j plus 1 by 2, and at I plus half especially this is also a unknown point and this is not exactly placed at the grid point. So, that is why to correspond to this grid point here we can just consider this one as I plus 1 here, j plus u I j by 2 here. Similarly, if you will just go for this j plus half point and here, then we can just write this one as like j plus 1 and j average of these 2 points. And similarly, if you will just go for here like I j plus half here, so this can also goes from j plus 1 j here by 2 here. So, I remain fixed, so that is why it is just taken the averages there, this equals to 0 here. And if you will just put here r equals to del t by del x and rearrange all the terms, since we will have this terms like u I plus 1 j term here, u I j term is here. So, u I j term is here, u I plus 1 j term is here, and we will have the terms containing u I j plus 1 here, we will have this u I j plus 1. So, combining form, if you will just arrange all these terms by separating all j plus 1 terms at the beginning and j term at the end of this equation here, we can just write this one as 1 plus CR. Since if you will just see here u I plus 1 j plus 1, so half it is also present there, half it is also present there. So, to both the sides we can just cancel it out from the denominator part. That is why we can just write this one as 1 plus CR I plus 1 j plus 1, 1 minus CR, if you will just see here u I j plus 1 minus 1 minus CR u I plus 1 j here, if you just see this term and this term here, minus 1 plus CR u I j term here, u I j term here. So, if you will just separate this u I plus 1 j plus 1 term here, we can just write this one as u I j plus 1 minus CR by 1 plus CR, and this is u I plus 1 j term, this is u I j plus 1 term. So, we can just write this form. So, if you will just see here, this is a explicit formula, since for I equals to 0, if you will just start the calculation here. So, I equals to 1 it will just take, so u 1 point it will, if you will just put here I equals to 0, then we will have a 0 value here, then we will have a 1 value here, and here also 0 value it will be there. But this u 1 j plus 1, it can be computed as u 0 j plus 1 here, which is known using the boundary conditions. If you will just go for like u 2 j plus 1, which can be computed, it will use like u 1 j plus 1 and so on, it will just move. And if you will just go for the analysis of stability for this method, your scheme it is expressed in the form of like u if it is expressed as the true solution, and u star is the like approximate solution. So, especially u minus u star, it is just considered as the error term there, and each of these coordinates, especially we are just writing I equals to p and j as q there itself, and the formula it is just replaced as in the form of e of p q, that is nothing but e to the power I beta p delta x and zeta to the power q there itself. So, that is why if you will just write these terms here itself, then we can just replace this one as like 1 plus CR ui plus 1 j plus 1. So, that is why it can be written as e to the power I beta p plus 1 delta x zeta to the power q plus 1. Next term 1 minus CR e to the power I beta p delta x zeta to the power q plus 1, since this is nothing but I j plus 1 term, minus 1 minus CR e to the power I beta p plus 1 delta x zeta to the power q here, since we will have this term like I plus 1 j there, minus 1 plus CR e to the power I beta p delta x zeta to the power q here. So, I j coefficient it is there, so that is why it is just written in this form. If you will just see here, we will have this common term that is in the form of e to the power I beta p delta x into zeta to the power q. So, both the sides if you will just cancel it out, we will have like 1 plus CR e to the power I beta delta x. So, this term it is just there, and zeta to the power q it has taken common. So, zeta is still itself there. Then we will have 1 minus CR. So, zeta to the power q I beta p delta x it has taken common. So, that is why we will have this term like zeta here. So, 1 minus CR. So, if it is just taken to the right hand side, 1 minus CR e to the power I beta delta x term. Here also same thing, we will have like only 1 is 1 plus CR is left there. So, that is why it has just taken to the right hand side. So, that is why the sign is changed to plus here. And if you will just go for this further modification of this equation, we will have like 1 plus CR e to the power I beta delta x by 2 plus 1 minus CR e to the power I beta delta x by 2 into zeta. This equals to 1 minus CR e to the power I beta delta x by 2 plus 1 plus CR e to the power minus I beta delta x by 2. Our aim is that we can just convert this series to the cos and sine form. So, that is why we are just multiplying these factors to get it in this trigonometry function form here. So, if you just combine this exponential coefficients here, so the first coefficient it will just give you like e to the power I beta delta x by 2 and e to the power minus I beta delta x by 2 here. So, which is nothing but it will just give you cos beta delta x by 2. Similarly, if you just take negation of this one, it will just give you ICR sin beta delta x by 2. And in the same manner, if you just go for the right hand side, we can just obtain these terms as cos beta delta x by 2 minus ICR sin beta delta x by 2. And directly we can just write zeta equals to cos beta delta x by 2 minus ICR sin beta delta x by 2 and cos of beta delta x by 2 plus ICR sin beta delta x by 2 here. Take the absolute value of zeta square, this equals to 1, that is mod zeta equals to 1. Hence, this scheme is unconditionally stable, and this is also better than a Lax-Wendroff scheme, since it is a natural extension of a Crack-Nicholson scheme, which is used in our earlier cases. So, the example can be considered as like del u by del t plus del u by del x equals to 0, where c is considered as 1 here, with the boundary conditions u of x0 equals to x and u of 0 t equals to t here. So, the question is asked to find the solution using Wendroff's method over x lying between 0 to 2.0. Especially you can just consider x equals to 0 here and L is equal to 2.0, and your t value it is just lying between like 0 to 1.0 with this mesh sizes which is just varying as like 0, 0.25, 0.5 in the x direction up to 2.0, and t is just incremented in the form of 0, 0.125 up to 1.0. If you will just see here, we have to follow like from 0 to 8 steps to get the or to reach at x equals to 2.0, and if you will just follows like 8 steps, we can just get t equals to 1.0 there. So, that is why we can just write it as like I is varying from 0 to 8 incremented with 1, and j is just varying from 0 to 8 incremented with the value 1 there. And if you will just consider like del t equals to 0.125 and del x as 0.25, r can be defined as del t by del x here. So, which is nothing but you can just write 0.125 by 0.25. So, which is nothing but 0.5 here. And this formula, if you will just see here that Wendroff's formula, which is just written as u I plus 1 j plus 1, this is nothing but u I j plus 1 minus C r by 1 plus C r into u I plus 1 j minus u I j plus 1 here. And if you will just put here C equals to 1 and r equals to 0.5 here, then we can just get it as like 1 in the numerator and 3 in the denominator here, and u I plus 1 j minus u I j plus 1 here. Computations will be performed for different cells here. So, if you will just see I is varying from like 0, 1, 2, 3, 4, 5, 6, 7, 8 and j is varying from 0, 1, 2, 3, 4, 5, 6, 7, 8 here. Since we are just considering these values as del t equals to 0.125 and del x as 0.25, where this x is just going from this region like 0 to 2.0. So, that is why if you will just divide in the form of 0.25 here. So, each of these grid spacings, then it will just vary in the form of like 0.0, 0.25, 0.50, 0.75, 1.0, 1.25, 1.5, 1.75 and 2.0. For the time scale, if you will just see here, so time scale is defined starting from 0 to 1.0 with the increment as 0.125. So, that is why if you will just see this increments in the table here also. So, that is just going as 0.0, then 0.125, 0.250, 0.375, 0.5, 0.625, 0.75, 0.87 and 1.0. And each of these cells, if you will just see here, that is as the first coordinate, if you will just see, that is as varying as I equals to 0 and j equals to 0 here. So, all these initial conditions, so that is just kept it as 0, 0.125, 0.250, since at t equals to 0 we have to define that one. So, that is why if we will just see this problem here over, then that is just defined at t equals to 0, u of x 0 equals to x here. So, that is why u of x 0 equals to x means at t equals to 0 if you will just see. So, that is just defined here, that is like 0.25, then 0.5, then 0.75, 1.0, then 1.25, then 1.5, 1.75 and 2.0 here. And if you will just see this boundary conditions, so especially the boundary values are defined at like u of 0 t here, that is t there. So, that is why this boundary conditions, that is at x equals to 0 if you will just see. So, that is also defined as T0, T1, T2, T3, T4, T5, T6, T7, T8. So, that is why from this prescribed values we can just calculate this boundary values, and this initial values can be calculated also, and it can be placed in that form there itself. For the first cell calculation, that is at I equals to 1 and j equals to 1, if you will just see this formulation here. So, that is especially written as u I plus 1 j plus 1, this is written as u I j plus 1 minus C r by 1 plus C r, u I plus 1 j minus u I j plus 1. So, starting value if you will just put here I equals to 0 and j equals to 0, then we can just obtain the values at u 1 1 there. So, if you will just see here u 1 1 value, that is as computed as 0.0417, which is nothing but if you will just see here. So, all computed values if you will just see here. So, C can be prescribed, and R is also given as del t by del x, that is as 0.5 here. So, and u 0 0, that is at I equals to 0 and j equals to 0. So, this value is known to us, since if you will just see here this 0 0 cell value for u, it is just taken as a 0 value there, and then u 1 0 minus u 0 1 there. So, all the values are known to us for this problem here. Since C equals to 1, R equals to 0.5 here, then this is separated equation, it is just known as that u I plus 1 j plus 1 is the unknown, and u I j it is a known value to us, and u I plus 1 j minus u I j plus 1, these two values are also known to us. wherever if you just see I is varying from 0 to n minus 1, since this cell counting value it is just a final value is going up to 8. So, that is why I will vary it from 0 to 7 here, incremented as a 1 by form here. So, that is why I equals to 0, 1, 2, 3 up to 7, we will just calculate these values. Since in the final form if you will just put here I equals to 7, so that will just take as a u 8th value, and j plus 1 values means j can vary from like a first initial value, it can be taken as from the first step calculation, then after that all other incremented value it can be calculated by using this equation. So, if you just go for this second value here, that is in the step of like j equals to 1 and I equals to 2 here, which can just take this value as 0.4028, which is nothing but if you just see here, this means that I equals to 2 here, j equals to 1. So, that is why we can just put I equals to 1 here and j equals to 0 there. So, that is why it will just provide us as the value of like u2 1. So, that is why we can just write these values as u1, this will take as 0 here, plus 1 minus CR by 1 plus CR, and it can be written as like, since I value is taken as 1 here. So, that is why it can also be written as 2, then j value is taken as 0 here, 2 0 minus u1, then j plus 1 means this is 1 there. So, this u11 value it can be taken from this like previous step of calculation from here, and then if you just see here u2 is 0 value, 2 0 means especially you can just say that I equals to 2 here and j equals to 0. So, this can be taken from this initial condition, and then we can just obtain the value of u21 there. Similarly, if you will just consider this 2 value here, then we will just consider I as 1 there and j as 1 there. So, then for this step if you just see here I equals to 1 and j equals to 1 here, then you will have like u22. So, then this can be written as like u11 plus 1 by 3 into u21 minus u12 there. So, u12 and u21 it can be computed from this previous step of calculations, and it can be used to obtain this value at u22 level there. So, further calculations it can just carried out like a sequential manner, whatever I have just explained like in the earlier cases. So, if you will just proceed in that form, then you can just obtain these values as 3 1 here. So, then 4 1, then 5 1, then 6 1, then 7 1, and finally 8 1 here. And if you just use all of these previous step values, then further steps like for increment of j in each steps we can just obtain these values in this form here. And in the final step if you just see here like u88 steps, you will just use this value in the u77 step and this value here to get this final value there. So, if we will just see here that ui plus 1 j plus 1, that is nothing but it can just take as a combined formulation of the values that at ijth level and I plus 1th jth level and ij plus 1th level. And this is just a simple calculation. If you just do, then you can just obtain at each iteration values up to last point. Thank you for listening this lecture.